Hello everyone, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as the concurrence regarding the quality of audio as well as video. If both had been perfect, just write perfect over the live chat and then we are ready to go ahead. Anyways, let me focus over the agenda behind today's video and the video which had been already streamed day before yesterday. Till day before yesterday, we had covered the part of integral calculus. The complete calculus part is not been over, but is still till the integral calculus we had already consolidated in day before yesterday's class. So from today onwards, we would start from vector calculus, and once we are done with the vector calculus, we would be proceeding forward. We will be talking about the concept of maxima, minima, series expansion. And similarly, in the same sequence, we would be talking about the probability distribution, density, complex variable, and end of the day, we would also be talking about the numerical method. And once we are done with the numerical method, our complete engineering mathematics would get over. Is that part clear to all of us? Is that part clear to all of us? So I would like to have the input from each one of you. The quality of video and audio, is it been perfect or not? If it's been perfect, just write perfect, and then we are going to start the today's class. Yeah. So it's been perfect. That's fine. Nah? That's fine. See, so in vector calculus, the few of the important formulas as well as the concepts I am going to bring in front of you. The first is been the application of the vector analysis. Probably you guys are well acquainted with the dot product and the cross product, vector addition and the vector subtraction. So few of the important part from where the questions are being repeatedly asked, we are going to focus on those important concepts. See, the area of the triangle, many of the times this problem had been experienced, probably as I can recall, once this problem had been experienced by the mechanical person and once this problem had been experienced by the electrical people. We need to get the area of a certain triangle and whose vertices are being known. Let's take their vertices are being A, B and C. So with the help of cross product as well, we can find the area which would be occupied by this triangle which had the known vertices A, B and C. Is that part clear? How do we do that? We had to stand at a certain point. Let's take we had stood at A. So now we had to extend the two vector. First A extended towards C, A extended towards B. So the vector becomes AC and the vector becomes AB. What we would do, we would take its cross product and we'll take its magnitude, and the magnitude is being multiplied with a half. We'll be getting the total area which has been occupied by this given triangle. Is that part clear? Keep in mind, this could have been done with the two different more ways. If you had been standing at point C, again you can extend the two vectors, the C extended towards A, C extended towards B, so it could have been CA cross of CB. And similarly, even you can stand yourself at point B as well, and there also you can extend the two vector quantities BA and BC. But keep in mind, you cannot take like CA and then cross AB. You had to stand at a certain point and two vector quantities is to be extended. You had to take its cross product, you had to take its determinant, and the half has to get multiplied. Half has to get multiplied. Is that part clear? Let me take an example for the better understanding, and probably you will be able to understand what exactly I had been calling off. I would like to have the input from each one of you. What would be the exact mode's answer for this given question? Let me take a problem. We had a triangle whose vertices are being known to me. Yeah. So this has been sort of this. This has been a triangle. Random vertices are being wrote over here. Let's take the vertices are being 0, 0, 0. Maybe this has been 1, 2, 3, and this has been 2, 0, maybe 1 you can write. I need to get the area which had been occupied by this triangle. May I know what would be the area which would be occupied by this triangle? My dear friend, you don't have to focus much here and there. Just focus over the application of cross product. What it states, you had to stand at a certain point. Let's take this has been the point A, this has been the point B, this has been the point C. And you are focusing over the area which would be considered by this triangle, and that would be equals to half times of vector which had been extended. You had to stand certain point. So I would request to each one of you, I think the A is been the best point to stand with. Why? Because the calculation 2 minus 0, 0 minus 0 becomes much easy. So once we take AC vector getting cross multiplied with AB vector, we will be getting its area which would be considered by this triangle. May I know what would be the exact answer for this given question? So what had been happening? So here it had been half, and here it had been 2 minus of 0, that's been 2, 2. And similarly 0 minus of 0, that's been 0, and similarly 1 minus 0, that's been 1, getting cross multiplied with, similarly 1 getting subtracted with 0, that's been 1, 2 is getting subtracted with 0, that's been 2, 3 is getting subtracted with 0, that's been 3, and you had to take its cross product. So probably everyone must be knowing about the cross product. With the help of this question, even I would try to explain how do we perform the cross product between the two vector quantities. For that we use the concept of determinant, where we would be having the 3 number of rows, 3 number of columns, obviously sir. So we are going to have the 3 number of rows and columns. Just a minute. So here comes 3 number of rows and 3 number of columns, and we start feeding the data over here, 0 and then 1, 2, 3. Yes, yes na? And this component would come under ax cap, ay cap and az cap. That is also okay, sir. Ax cap, ay cap, az cap. Just a minute. Ax cap. Anyways, we had also had a short trick which we have studied in class 9th and all, where we can find the area of the triangle with the help of those vertices. But I don't want to make so many formulas. Just focus over this problem and tell me what would be the best most answer. So the new student who had joined now, I would like to ask from each one of them, may I know what had been the best most answer? What had been the best most answer? May I know the brightness has been a little bit dull or what? Let me check it out. Let me increase the brightness a bit. So I would like to know from each one of you, after increasing the contrast, whether the quality of picture has been improved or earlier one was better. Now, see, the contrast has been increased. Yeah. So here, the same process has to be followed. The ax cap, 0 gets multiplied with the 3, that's been 0, and that's been minus of 2, and similarly minus of ay cap. The 2 gets multiplied with the 3, that's been 6, minus of 1, that's been 5. And similarly, here comes az cap, and that had been 2 to the 4, 2 to the 4, 2 to the 4. You had to get its determinant. May I know what would be this determinant? So this is simply gonna be minus 2 to the power of 2, that's been 4, plus of 25, plus of 16, and that has to get multiplied with half. That has to get multiplied with half. So this becomes root over of 4 plus of 25 plus of 16, and that value has to get divided with 2. So the result which we are supposed to get is gonna be 3 root 5 getting divided with 2. Yes, no? Yes. So everyone had been getting the same answer? Yeah, this has been the answer now. Now I would like to ask another question. I have seen very rare this sort of problem, but yes, this sort of problem can also get designed in future. The 3 different points must have been given in this problem. What they can say? They can say 0, 0, 0, maybe not 0, 0, 0, 1, 0, 1, 2, then 0, 3, 6, then 0, 4, maybe k. Find the value of k such that these 3 points are being collinear. My dear friends, if these 3 points are being collinear, may I know what's the conclusion you can bring? My dear friend, if these 3 lines are being collinear, at very beginning you have presumed that this has been the 3 different points of the vertices of your triangle. In that case, the area which would be framed by this collinear line would be simply 0. Is that part clear? So yes, if these 3 points are being collinear, you can presume that they had been the 3 vertices of a triangle, and as they had been a 3 vertices of a triangle, from the area formula, half times of AC cross of AB would result the area. But as far as these 3 points are being collinear, their area would be 0. So from here onwards, one of the important outcome can also be brought anywhere if the problem is being framed in such: find the value of k. For these 3 points to be collinear, you had to find their what? Area, and the area has to get compared with 0, because if the 3 points are being collinear, they would not frame any area at all. Is that part clear? Now in the same sequence, Now in the same sequence, area of parallelogram. My dear friend, the area of parallelogram, you just focus over this structure and this structure. This parallelogram is being the extension of this triangle. If you'll extend in this manner, you yourself would be able to understand the parallelogram had been created. And the area which had been occupied in this region and the area which has been occupied in this region had been very same. So what we are going to do, we are just going to add the area which had been subtended by this triangle and this triangle, as both had been same. So it's going to be half times of this factor plus of half times of this factor. Half and half added together becomes 1. Put together the result which had been coming in our hand, it's been AB cross of AC. So from here onwards, whenever you had the problem related to the parallelogram, what you do, you stand at certain point, you extend the two vectors, let's take it the AB and let's take it the AC, and you had to just take the determinant of AB cross of AC, or I can say it's just been the double of the triangle which had been occupied earlier. Agreed? So this part must also be known to all of us. Orthogonal and orthonormal vectors. I had seen many other times the problem used to ask, what's the worth of k for which the vector A and vector B are being orthogonal to each other. Anyways, for those understanding, we had to have a little bit idea about the orthogonality and orthonormality. Yeah, the problem states the two vector A and B are said to be orthogonal if their dot product is equals to 0. That means both of the vectors are being perpendicular to each other, and once you perform the dot product between the two vector quantities, A dot B is equals to magnitude of A magnitude of B into cos of theta. If theta is being 90 degree, definitely this value becomes 0. So from here onwards, I can simplify the complete statement in such that the two vectors are being said to be orthogonal vectors if they had been perpendicular to each other. Now, two vectors A and B are said to be orthonormal if their dot product is equals to 0 and magnitude of both vectors are unity. Agreed? Like AX cap, AY cap, both magnitude had been unity, and once you'll perform their dot product, obviously their dot product would also be 0 because they had been orthogonal unit normals. Yeah. Now in the same sequence, we would be talking about the differential operator as well. My dear friend, the differential operator is being referred by del operator, or is also called a number operator. It's been referred as a dou of dou x in the direction of ax cap plus of dou y in the direction of ay cap plus of dou z in the direction of az cap. As far as the del operator is being concerned, it can be applied in three different scenarios. It can be applied over a scalar field, would result a vector field, and that operation is being called as a gradient operator. And similarly, it can be applied over a vector quantity, results a scalar quantity, and that vector is called a divergence operator. And similarly, it can be applied over a vector quantity and results another vector quantity, it's being called as a curl. So keep in mind, from here onwards, we are going to focus on the three different vector differential operator. Let's take f is being a scalar quantity, and del is already been a vector quantity. So vector quantity getting short multiplied with the scalar quantity, obviously the result is gonna be vector quantity, and this operator is being called as a gradient of scalar field f. Gradient of scalar field f. So most of the time in mathematics, whenever the question gets asked, no, they won't say it would be gradient of f. Whenever the del f has been written, by default you had to understood, you had to perform the gradient of a scalar field f. Is that part clear to all of us? There should not be any problem as such. Now, in the same sequence, let me move forward once again. Divergence operator is being applied over a vector field and results a scalar field. So obviously the dot product has to be performed. Why? Because the dot product is being performed between the two vector quantities. Let's take, we had the two vector quantities. First is vector differential operator and the second is being the vector quantity itself. And the result as the dot product is being performed is going to be a scalar quantity. There should not be any doubt as such. Now in the same sequence, we are going to take the third scenario as well. There we would be talking about the curl operator. As it had been communicated earlier, the curl is being applied over a vector quantity, which talks about the curly behavior of a vector over a certain point over 3D space. But anyways, lump sum I can say the curl is being applied over a vector quantity and results another vector quantity. So may I know whether the dot has to be applied or the cross has to be applied? Obviously, sir, the cross has to be applied. There is no doubt as such. The cross has to be applied because the cross gets applied over the two vector quantity and results another vector quantity. So whenever this sort of mathematical segmentation you get, no, basically you had been dealing with the divergence and here you had been dealing with the curl. Yes, and the del operator remains ax cap dou of dou x plus of ay cap dou of dou y plus of az cap dou of dou z. Now the important thing I would like to tell to you guys, if you guys are from mechanical, civil, chemical, you need not to by heart the formulas which are being useful: gradient, divergence and curl in spherical and cylindrical coordinate system, because rarely the question get asked from this spherical and cylindrical coordinate system. And if you guys are from electrical, electronics and instrumentation, no, you had to by heart all of three formulas with gradient and divergence and curl, because I had seen, if you are from electrical, electronics and instrumentation, many of the times the question are being framed where the divergence is being performed over a vector field, where the vector field is being represented in spherical coordinate system. Is that part clear to all of us? Spherical coordinate system. So there should not be any doubt till this moment of point. So I think this is a formula probably almost all students must have remembered it. Gradient is also being called as a del of scalar function phi, and that had been defined as, see what had been, how it had been defined. The phi would be partially differentiated with respect to the x, and this component would fall in the direction of ax cap. Partially differentiation with respect to the y, it would fall in the direction of ay cap, and similarly it would fall in the direction of az cap as well. Is that part clear? My dear friend, the gradient is also being called as the vector differential operator. Vector differential operator. Yes. It's also been called as a directional derivative. So many of the times, specifically in mechanical and civil, I had seen rather referring this operator as gradient, they refer this as a directional derivative. So whenever for a scalar field you had to perform the directional derivative, put together you had to perform the gradient, and the formula must be known to all of us. Few of the key points. First, it is only valid for the scalar point. Yes, that we had already seen. Gradient of a scalar point function is a vector quantity, that is we have also seen. That means the input is gonna be a scalar function and the output is gonna be a vector function. It gives the maximum rate of change. That part you can remember, because this is not the right time to discuss more about the gradient. If I'll discuss the concept of gradient thoroughly, probably I had to spend 3 to 4 hours over the gradient itself, and this is not the right time to discuss in such an intense manner. Could you understand what I'm saying? So just understand in this way. If you perform, if you calculate the magnitude of the gradient of a certain scalar field, that talks about the maximum rate of change. Maximum rate of change. Yes. So this has been the formula in Cartesian coordinate system. For the electrical, electronics and instrumentation student, they also had to remember the two remaining formulas that had already been discussed when we were discussing about the marathon of electrical and electronics in Hindi. Yeah. And similarly, here comes the divergence. How the divergence is being defined? Obviously del dot f, where the del is been a differential vector operator and the f vector, obviously it's been a vector field. How the divergence is being applied? What you have to do? First, the component of f would have the three component. The first component which had been falling in the direction of ax cap, ay cap, az cap. The component which has been falling in the direction of ax cap, let's take it's been f1. In the direction of ay cap, it's been f2. In the direction of az cap, it's been f3. So what we had to do? We had to do the partial differentiation, f1 with respect to the x, f2 with respect to the y, and f3 with respect to the z. And from there, we would be finding the divergence of a vector field over a certain point over the 3D space. Yes. Few of the important point, probably the student who had learnt a bit about the divergence must be knowing about it, but no issue. Divergence is only valid for the vector point function, obviously. Point function I cannot explain, at least over this marathon, but yes, just try to understand in this way. The divergence has been applied over a vector quantity and results another scalar quantity. It is calculated by the dot product of the del operator with the given vector quantity, that we have already seen. Why the dot product is being applied? Because the result which we require is being a scalar quantity. It is used to calculate the net flow of the vector quantity, that we had already seen. And now if del dot f is equals to 0, then f vector is called solenoid vector, incompressible vector. Keep in mind, from here the questions are being concurrently and repeatedly being asked. A vector is said to be a incompressible or solenoid vector if its divergence is being 0. Anyways, another name is also being allocated along with this, and that's been divergence free vector. So you can expect specifically electrical electronics and instrumentation, they would get a little bit tougher question. For the mechanical, civil and chemical side, no, usually this sort of problems are very frequent, where they would be giving a vector quantity, there a certain unknown quantity k would be attached, and they would ask find the value of k for which the given vector is being incompressible or maybe divergence free. So easily you will be able to get this answer. You will be able to get this answer. Agreed now? Now, in the same sequence, we had been talking about the curl as well. The curl would be applied over a vector quantity, would result another vector quantity, del cross f, the same thing, as we had been performing the cross product. So here becomes ax cap, ay cap, az cap, the partial differentiation with respect to the x, y, z, and the component of the given function which had been following the direction of x, y, and z. X, y, and z. Is that part clear? Few of the important conclusion. It is only valid for the vector point function, that is also. Curl is basically used to find the rotational behavior of the vector field. Anyways, I won't be able to tell much about the rotational field and the curly behavior of a certain vector over a 3D space, but for the time being, you just understand in this way. The name itself talks about the behavior. The curl calculates the curly behavior of a vector field over a certain point in the 3D space. Yeah. If curl f is equals to 0, the field f is termed as irrotational. That is fine, sir. That is fine. Directional derivative. Find the gradient of a scalar potential that is being del of phi. Find the unit vector. Yes. Directional derivative. Directional derivative. What does it mean of it? That means we want to have a direction with certain derivative component which are being involved, and as we had communicated earlier, obviously we had been discussing about the gradient operator only. Find the gradient of a scalar potential, that is been gradient of phi. Find the unit vector. How do we find its unit vector? Just we'll take its magnitude, that we had done it, and then we have got it the value over here, that we have got it the value over here. So, and that's been nothing but the directional derivative. It gives the rate of change of a scalar point function. Yes, yes, this has been a most important outcome. Keep in mind, you had to remember these three formulas. You had to remember these three formulas. The question do come from this segment repeatedly. Divergence of curl of any arbitrary vector function would always be 0. Any arbitrary vector function you can take. First, if the curl is been performed, and then if you are intended to perform its divergence, the result would always be 0. Similarly, any random scalar function is being chosen, the gradient is being calculated first, and if you calculate its curl, by default the result would always be 0. And here this is called a Laplacian operator, where the gradient is being applied over a scalar field, and then we have applied the divergence. So put together, it's going to be del square of phi. Del square of phi. Is that part clear? Is that part clear to all of us? Now, vector integral theorem. The vector integral theorem, I can say for the all of the branches. If we'll talk about the vector calculus, the integration part is being the most important part. Either it's been the line integration, maybe open or closed form, and similarly surface integration, either it might be open or closed form. Let's see what it states. It is used to simplify the vector integration. It gives the relationship between the closed line and open surface integration. We had been talking about the Green's theorem. My dear friend, probably you must have practiced few of the questions from the Green's theorem. What it does and which kind of the problem it used to have. My dear friend, you will be having a closed contour. And not only you will be having a closed contour, even it would have a uniform direction, that it starts from a certain point and gets terminated over the same point. And then you had to perform the line integration. Usually the structure of the problem used to be the closed line integration of f of xy f of xy dx plus of g of xy dy, and you had to perform a certain process. Probably you must have understood what I exactly wanted to say. So statement is been phi of xy, psi of xy, d phi by of dy, d psi by of dx to be continuous function over a region R bounded by a simple curve C in xy plane. And according to the Green's theorem is been close that integral of phi dx plus of psi dy is equals to of open surface integration. So the closed contour must have been enclosed a certain surface. We had to take the reference of that closed surface only, and now we had to take a partial differentiation, and we will be getting the answer as well. We will be getting the answer as well. Yes, Surajit, I am taking few number of numericals as well. No issue. So take care, Surajit. So now, as you said, we are going to take the few number of numericals as well. So let me take the one numerical based on the concept of Green's theorem. See, let me design a problem for you guys. See which kind of problem get asked most of the time from the Green's theorem. Usually you will be having a cyclic line integration, which we also call it closed line integration. Sometimes the L has been written, the L refers the line and C refers the contour. The concept remains same. Yes, is that part clear to all of us? And now you can have 2xy dx, and then you can have three x dy, and you have to perform this line integration. So whenever the line integration, the closed line integration has to be performed, the reason must be given at which the closed line contour is being performed. So we have taken that yes. Let's take the vertices are been 1, 0. It's been 1, 0. It's been 1, 1. It's been 0, 1, and it's been kept at 0, 0. It's been my x-axis. It's been my y-axis. It's been my y-axis. My dear friend, whenever the rotation had been into the anti-clockwise, the integration what we perform with the help of Green's theorem, no, minus sign gets multiplied. And if it must have been in an anti-clockwise direction, definitely whatever the formula is been written, we can use that formula and we can get the answer as well. So keep in mind, the plus and minus sign totally depends the rotation is been clockwise or anti-clockwise. Clockwise or anti-clockwise. So here plus would be used when the integration or rotation is being anti-clockwise. The minus sign would be used when the rotation is being clockwise. And as per the formula, we had to perform the surface integration. Yeah, surface integration. May I know what would be the limits of this surface integration? We had to take the reference of the closed contour, which area has been bounded. Obviously, this area has been bounded, where the x can travel its value from x is equals to 0 to 1. So x can change or take its value from x is equals to 0 to 1. Y can take its value from 0 to 1. 0 to 1. That is all fine, sir. Should I be choosing the minus or should I be choosing the plus? As the rotation is being clockwise, obviously the minus sign is to be chosen. Minus sign is to be chosen. Tell me what would be the answer for this given question. The 1 minute had been allocated to you guys. Tell me what could be the best most answer for this given question. Yes, 1, yeah, 0 to 1, that's fine. Nah? But I want to have the input from each one of you. What could be the best most answer for this given question? Obviously, the minus sign would be attached over here. Now, what we had to do, we had to focus over the multiplier of dx and similarly the multiplier of dy. Multiplier of dx is being taken as f, which is supposed to be the function of x and y. And similarly, multiplier of dy is being taken as a function of x and y, and that function is being referred by g. And what we do over here, we take the partial differentiation of g with respect to the x and partial differentiation of f with respect to the y. Sometime the mistake takes place at this point only. What the student do, what they would think, the f would get partially differentiated with the x and the g would get partially differentiated with the y. No, but here the alternate manner that the partial differentiation is being taken place. And here again we had to bound by the differential area over the differential surface. So obviously it's mean the dx dy. So here it becomes minus. Again the x goes from 0 to 1, y goes from 0 to 1. And now what we had been doing, now the g has to get partially differentiated with the x. So here the factor is being 3 minus f has to get partially differentiated with y. So here we had the factor as minus of 2x, and here comes dx and dy. One thing has been quite sure, the function has been the function of x, so at least the integration of dy can be performed separately. And once we had been performing the integration of dy separately, what had been happening, the integration of dy is going to be y, the limit is being from 0 to 1, so simply we can write y with its limit from 0 to 1. And once we'll take the integration, so here is going to be 3x minus of 2x square divided by f2. So simply I could have written this as a 2x square, and here also the limit is being 0 to 1. Agreed, no? How much answer we had been getting, my dear friends? And yes, so here this goes off. So once we'll start feeding the data over here, so this becomes 1, this becomes 3 minus of 0, 3 minus of 1, 3 minus of 1. My dear friend, whenever this has been attached with the x, no, once you'll feed the x as 0, no, by default this factor becomes 0. So upper limit minus of lower limit hardly make any sense. So the answer is being 2, and the minus sign is coming all the way from top to bottom. So answer would be simply minus of 2. So the best most answer is being minus of 2. Is that part clear to all of us? Now I would like to ask from each one of you, the student who had been watching my live stream currently, how many of them are from electrical, electronics, instrumentation, or civil mechanical? At least I should have a little bit idea from which branch you guys are from. From which branch you guys are from? Which branch? So I should have a clear-cut idea from which branch you guys are from. Is that partly what I'm saying? So just try to understand what exactly I wanted to communicate over here. ECE. So according to that, I would try to alter the pattern of the question. Okay, metallurgy, Satpal Singh. Okay, that's fine. Vanya, EC. Okay, EC. Govind, Durga. Okay. No. Please, I would XE. Okay, engineering, ECE. Most of us are from ECE, no? So let me take few typical question as well. See, although I am not going to take the difficult most question which I had taken in our main channel, but still this kind of the question can also get asked. Yes. May I know how will you perform the closed line integration with this sort of problem? Yes. This has been a closed line integration, which let's say it starts from this vertices, goes till this, and then get the value. Tell me, how will you approach this sort of problem? Once in a while, this sort of problem get experienced by the gate people. I have seen probably 5 years back in electrical or maybe instrumentation. So see, in that case, what we had to do, again, you can apply the Green's theorem. Let's take the vertices are being A, B, C, D, and E. But what you had to do, you can take the reference of this triangle separately, and you can take the reference of this triangle separately. Why I am doing so? Because in this closed contour, the rotation of the contour is being clockwise, whereas in this contour, the rotation of the contour is being anti-clockwise. Although you might be performing, or you might wanting to performing to integration in once through, but you can't do so. Why? Because in this region the rotation of the integration is being clockwise, and in this region the rotation of the contour is being anti-clockwise. I would like to ask from each one of you, let's take this has been taken as a segment number 1, and this has been a segment number 2, where the positive sign would be involved and where the negative sign would be involved, as it had been involved over here. So obviously, sir, here in this region, no, as we had been moving in the clockwise region, once we'll use the Green's theorem, once we'll differentiate and once we'll take its limit, obviously limit would be taken for this triangle only, but there minus sign would be attached. Yes, and here the plus sign would be attached. One student has been asking, sir, how we will be taking the limit? Probably with the help of double integration, with the help of either vertical strip and horizontal strip. You already know how to perform the area given by a certain closed structure. So either you can take a vertical strip, either you can take the horizontal strip, and you can perform the area under this curve as well as this curve. And end of the day, the subtraction between these two factors would result your final value. Yes, minus and plus. Agreed? No? I expect in future this sort of problem can definitely be asked. But still, I'm saying in marathon, I'm not going into the detailed analysis of the engineering mathematics. Otherwise, probably next 15 to 20 hours, we would be talking over the maths only, which is not possible for you as well as me. Yeah. So yes, this part must be clear to all of us. So few of the important points which we had discussed so far. The first important point is being, if you had a triangle and if their vertices are being known, easily with the help of cross product you can find its area which had been occupied by this system. Similarly, now the next kind of the problem which can ask, which I feel which can be asked, it's been the problem related to the Green's theorem, where we used to perform a closed line integration, and obviously with the help of Green's theorem. Is that part clear to all of us? Now, similarly, the Stokes theorem. The Stokes theorem is another theorem where the closed line integration can be converted in the form of open surface integration. It is used to simplify the vector integration. That's fine, sir. It gives the relationship between the closed line integrand and open surface integration, as it had been done by the Green's theorem as well. Statement: surface integral of a curl of a f vector along the normal to the surface f bounded by the curve C is equals to the, anyways, what I'm saying, if you had been performing the closed line integral of a vector quantity f over differential displacement dl or dr, that has been very same as open surface integral, may I know what would be the limits? The limit would be just taken by the closed contour and its limit. The curl has to be performed over the f, and then we are going to just perform this value. Yes. Manisha Sukla, what is been the function? Manisha, what I am saying, the function could be anything. But here the problem is being framed in such a way where most of the student might come into the little bit confusion. I'm not saying what had been the function. Function could be anything. Function could be maybe 2x, function could be maybe 3 of x, anything it could be. Should I frame a question based on this concept? Yes or no? I would like to have the input from each one of you. Should I frame the problem based on this concept? If you'll say yes, I'll frame a question as well. So let me design a problem. There are too many important concepts which we can taught over the engineering mathematics. Too many. Even I think if we'll start teaching mathematics, no, it can go even 130 to 140 hours to really understand the basic crux of the engineering mathematics. I would like to have the input from each one of you. I had to perform the closed line integration of, let's take, it's been 2y dx plus of x dy in reference with a closed contour, and let's say the closed contour is been something like this. Like this it had been. I would like to have the input from each one of us. Let's take this vertex is been at 1, 1, 1, 3, 3, 1, 3, 3, 2, 2. I would like to have the input from each one of you. What would be the best most answer for this given question? And you can expect this question in near future, because it has been a very simple question, but most of the student used to by heart the formula and probably they would not be able to crack this problem out. Tell me what would be the best most answer for this given question. This has been the question in front of you. The closed line integral of 2y dx plus of x dy has to be performed over a closed contour which has been clearly given over this problem. Tell me. So the next 1 to 2 minutes has been allocated to you guys to crack this problem out. Tell me what could be the best most answer. So Manisha Sukla, आपको ये डाउट था कि सर फंक्शन क्या होगा? So the function is been there in front of you, and such a nice function I had taken. Once you solve this problem, no, the problem remains very easy. The problem remains very easy. So the next 2 minutes had been allocated to you guys to get the answer for this given question. It's been a bit tricky question. चलिए तो 2 minutes is being given to you. 2 minutes. Tell me. It should not be taking this much time, na? It should not be taking this much time. I need to get the answer for this given question. Tell me, my dear friends, how much answer we are supposed to get for this closed line integration, which can be easily deduced with the help of Green's theorem. Although we can use the Stokes theorem as well, but definitely I would try to avoid the Stokes theorem at this moment of point, because there are so many operators are being involved, so many processes are being involved, including the curl as well, including the curl as well. So definitely straight away with the help of partial differential equation, which are being used in case of Green's theorem, I would try to smash this problem out. Tell me, what could be the best most answer? No answer so far. As per the Manish Sukla, answer has been 4. Sorry, I was telling Manisha. Manish. Okay, Manish. Answer has been 4. Anyone else apart from Manish? Anyone else who will contrary the Manish? Ah, dekho Manish. Yes. 4 and minus 4. The two answer had come from the Manish side. And that's what I'm saying. Many of the times this doubt do also come into the picture, whether the result would be plus 4 and minus 4. Vanya, what has been your answer? Sasank, what's been your answer? And similarly, Kritika, what's been your answer? Tell me, what could be the best most answer for this given question? Anyways, if you are getting the wrong answer, no issue, no. Nobody is going to judge you, my dear friend. Here the competition is, your competitor is only you only. You don't have to think whether something bad would happen or my feedback would become bad. Whatever the answer you are getting, just put it over the live chat. So at least I would be able to read your psychic where exactly you had been making mistake, and according to that I would be able to explain the thing into the better way. See what had been happening, my dear friend. As we had been talking about the closed line integration, even this closed line integration can be bifurcated into the two separate closed line integration. Yes or no? Yes or no? So what we could have done over here, my dear friend, we could have taken the first closed line integration, and this has been this. Let's take this has been the first closed line integration, and here we had been 2y dx plus of x dy. And similarly, the second closed line integration is being, so far we had seen the closed line integrations are being distributed in the form of open line integrations. But here, this closed line integration has been such a beautifully designed that this closed line integrations are being bifurcated into the two different closed line integration. Different closed line integration. Yes or no? And here also, you will be having 2y dx plus of x dy. Probably the next process must be known to all of us. What happens? the factor which gets multiplied with the dx is being called as f. The factor which gets multiplied with the dy is being called as x. And now this x is going to get differentiated with x, and similarly this 2y is going to get differentiated with respect to the y partially. So what would happen? First differentiation of this with respect to the x, that is simply 1, and similarly differentiation of 2y with respect to the y partially, and that had been minus of 2. That is for sure. Yeah, yes sir. And again, now the closed line integration would be converted its component into the open surface integration. Which open surface? The amount of area which has been enclosed by the first closed contour. And here it becomes dx dy. Now I would like to ask from each one of you, now this would be regarded as a positive or negative? My dear friend, in first closed contour, as we had been moving into the anti-clockwise direction, definitely it would be regarded as a positive. Similarly, if we'll be focusing over the next component, here also the closed line integration is being changed it to the open surface integration. And what we would be doing over here, now the 2y dx plus of x dy, the same process is going to get fall, and that's been 1 minus of 2, and here it becomes dx and dy. Yes or no? Yes sir. And here it becomes minus. Why minus? Because you yourself would be able to see here the rotation of the contour is being clockwise, and here the rotation of the contour is being anti-clockwise, ACW. That is fine. Yes sir. Now what we can do, this 1 minus of 2 business is going to minus of 1, and similarly this 1 minus 2 business is going to be plus of 1. So if you want, you can mark it minus of 1, and this has been left out with the dx dy, dy, and similarly this has been plus of 1 dx dy. Yes. And one of the best thing regarding this problem, my dear friend, the area which has been occupied by this region, the area which has been occupied by this region has been very same. This has been a congruent triangle. That means they are just going to overlap to each other. And if it has been happening so the area which we will be calculating over here, area which we will be calculating here would be same, and as their signs are being different, the answer is being simply 0. If you want to know the area which had been occupied by this triangle, so first you have to use the formula half times of base. May I know what had been the base over here? 3 minus of 1, that's been 2, into altitude. May I know what had been the altitude? This is going to be the altitude. Here the value of x is being 1, and here the value of x is being 2. So 2 minus of 1, that's been 1. Put together 1 unit square. So 1 do come over here, 1 do come over here, the answer is being 0. Manish, could you really understood what exactly I wanted to communicate? Apart from Manish, nobody had given the answer. This is not the correct way to attend the class. Try to solve few number of questions as well. Yes. And Surijit, as you were asking, sir, why don't we take few number of questions? And as we had been taking few number of questions, you are not replying. This is not the correct way, na? No issue. Okay, then we had to move forward taking few number of theories as well. Try to be interactive. If you are not being interactive, anyways, we had to finish this PDF at any cost. Gauss theorem or divergence theorem? My dear friend, the theorem is used to simplify the vector integration. Which vector integration? Vector closed surface integration. It gives the relationship between the closed surface and open volumetric integration. You must have been seen where the integration of the closed surface integration has to be performed over a certain vector quantity, maybe over a cube, maybe over a cuboid, or maybe a complete sphere. Now what we can do with the help of divergence theorem, that closed surface integration can be converted in a form of volume integration. So what happens? If you take an example of cube, if you had been performing the closed surface integration, what happens? The complete closed surface integration has to be distributed into the 6 different open surfaces. Either it's been top, bottom, right, left, front, and back. And the carrying out the 6 different integration has been a very challenging task. So obviously those process and those complexity can be easily reduced with the help of divergence theorem. Is that part clear? And here it becomes the closed surface integration of f dot ds, where the ds has been the differential area with the unit normal, is been very same as the open volumetric integration of divergence of f dv. Yeah. So probably till this point, I don't find any of the student would have any kind of doubt. Now focus over the maxima and minima. Probably you guys must have a clear-cut idea about the maxima and minima. See, maxima and minima for a function of a one independent variable. So as far as the concept of maxima and minima are being concerned, no, I would be bifurcating the concept of maxima and minima into the two parts. So let me focus over the concept of maxima and minima. Maxima and minima. Yeah. Concept of maxima and minima. Basically, by keenly watching over the question itself, no, basically you will get to know the problem is being one variable or two variable, maxima and minima. Like if you had been dealing with a problem like function f of x may be a cubic equation. So you can see the number of independent variables which are being involved with this function is being only and only one. So this would be called as single independent variable based concept of maxima and minima. Why we had been dealing separately? Because the process of calculation of maxima and minima are being bit different. Similarly, if you take another question, where again we had been in search of finding the maxima and minima of the given function, and let's take the functions are being somewhere x cube minus of y cube. You yourself would be able to understand whatever the function which is getting decided by this component had the independency over the x as well as y. So keep in mind, if you write this function is being a function of x and y both, and now this function would be falling over the double variable function, and its concept of maxima and minima would be falling under the double independent variable based on concept of maxima and minima. Yes, na? Okay then. So let me go back and let me see. Just a minute. Let me see which are the different steps which we follow. What we do, if we had been dealing with the one independent variable based concept of maxima and minima, first we take the differentiation of the given function with respect to only one independent variables we had. If that independent variable is being x, so we'll differentiate with x. If the independent variable is being a, we will differentiate with respect to the a. Put together, the given function would be differentiated once with respect to its independent variable. So that is what it had happened. Like y is being a function of x, so at very beginning y would be differentiated with respect to the x, and now it would be compared with 0. So all of the possible real values of y where dy by of dx becomes 0, or I would say the slope of y with respect to the x becomes 0, or the slope over the y is being parallel to the x, or tangent drawn over the y is being parallel to the x, there that point is called as a stationary point. Stationary in Hindi it's called ruka hua. Stationary, what does it mean of it? That means the slope is being stuck to 0. Yes, keep in mind that is being called as the stationary point. My dear friend, in future the stationary point could be maxima, could be minima, or could be even saddle point as well. So most of the questions which gets asked, no, they usually get asked from the concept of maxima and minima, but here and there few other questions are also being asked from the concept of saddle point as well. Yes, now as it had been known, the stationary point dy by dx is equals to 0. The all possible values of x which makes dy by dx is equals to 0 are gonna be the stationary point, but we are not well aware whether those stationary points are being the points of maxima, minima, or saddle point. For that, the further investigation is required to be carried out. How do we do so? We take the double derivative, and now the double derivative of y, and we would be feeding the stationary points, and if the stationary point is being fed, let's take the stationary point is being fed over the double differentiation of the function, and if the value is being lesser than 0, that x is equals to a would be qualified as a point of maxima. And similarly, if f double dash a is being greater than 0, that point would be qualified as a minima. And if function has no extrema, minima or maxima at x is equals to a, f double dash a would be equals to 0. F double dash a is equals to 0. Yes. That we had been talking about the stationary point. So this key point, let me again recall. For a continuous and differentiable function f of x, the value of x for which the slope of the function f dash x is equals to 0 are called the stationary point or turning point or the critical point. Why it's also called the turning point? Because it's been the point where the slope is supposed to turn its polarity. See, earlier the slope was positive and from here the slope would become negative. Is that part clear? There are the point of x in the domain where the f dash x is equal to 0, the saddle point. A point where the function is neither maximum nor minimum is said to be a saddle point. At such point, the function is maximum in one direction while minimum in another direction. Like if you thought of a curve which has been keep decreasing its slope, and let's take here the slope had become 0 and we are expecting the maximum would take place, but again it has started increasing. So you yourself would be able to understand till this span it was making a sort of maxima curve at this point, and in this span it was making sort of a minima at this point. And basically neither the minima is being made nor the maxima is being made, because for making a maxima, what we say, the maxima is been a point locally where the worth of the function is being maximum, but this is not been the case. This is not been the case. Yes, if you'll take this 2 point, definitely at this point the worth is being maxima in compare with this point. So this point is being called as a saddle point. The saddle point can be bifurcated as an increasing saddle point or decreasing saddle point. You can see this has been an increasing in nature, so I can qualify this as a increasing saddle point, and similarly this could have been written as a decreasing saddle point. This could have been written as a decreasing saddle point. Yes, far. Agreed, my dear friends? So till this point I don't find any of the student would have any kind of doubt. In case of maxima, the slope is being positive and it is being keep decreasing, and at saddle point, or sorry, at its stationary point the slope becomes 0, and from there onwards the slope becomes negative. So I would say the maxima has been a point at which the slope changes its worth from positive to negative. If you don't understand, you can take in this way. How the slope is being calculated? First we draw the tangent. And once you'll see the tangent over here now, the slope of this tangent is too steep, but here it is becoming lesser. Here it is again becoming a lesser, and here it had become 0. So you can say here it was a strong positive, here it had been weaker positive, and here it had been 0, and from here it had been negative, strong negative, more negative. So from here onwards we can say the maxima has been a point where the slope offered by the function changes its polarity from positive to negative. Yes. Similarly, local minima. If we'll talk about the local minima, the same fundamental gets reversed. You yourself would be able to understand this has been my local region at which we ourselves would be able to understand this has been a point where the minimal most value of the function is being retrieved. So obviously, sir, this is going to be the point of minima. But mathematically, how will I define it? The slope is been negative. How I can say the slope is been negative? The x is been keep increasing, the y is been keep decreasing. Slope is been negative. Slope is been strong negative, lesser strong negative, the slope is become 0, and now it has been lesser positive, strong positive, more strong positive. So put together, this has been a turning point of a slope. Before a stationary point, the slope was negative, and just after the turning point, the slope has been positive. So whenever the slope of a function turns from negative to positive, provided the function has to be differentiable at the point of turning, by default the given system or the given function becomes the minima at this point. No, Vanya, it had been clearly stated earlier. If you really want to enjoy the mathematics, you had to come across our complete video, because such a huge amount of effort had been put in for the consolidation of this complete PDF, and we ourselves had also got a certain rules and regulation. We cannot go beyond that rules and regulations. So yes, if you really wants to see the complete PDF, you can just take the screenshots of the all of the important formulas or the fundamentals which looks something new for you. For that, what you have to do, you have to look my last video and this video. That only you can do. No, I won't be able to share this PDF. Yes. Now, step to find the absolute maximum and minimum of the function in the interval of a comma b, the same process which it had been communicated earlier. How? First, you have to take its first derivative, compare with 0, get the stationary point. A stationary point could be the point of maxima, point of minima, point of saddle point. Take the double derivative, feed the value of x as a, that had been the stationary point. If the result is been negative, that means the given f of x is been making a maxima over here. If it has been negative, it making a minima over here. And similarly, if it is being 0, it could be a saddle point of inflection. Point of inflection. Yes. Similarly, for the two independent variable, I had seen for the electrical, electronics and instrumentation, most of the questions which are being asked from the concept of maxima and minima now, they are being having the two number of independent variables within the same function, as the z is being the function of two independent variables x and y. What we do? We used to calculate p, q, r, s and t, all of the possible derivatives. How the p is being defined, that we have already discussed when we were talking about the partial differential equation. But anyways, let me show once again what we are going to do over here. First, we will calculate p. How the p is being defined, my dear friends? The p is being defined as the partial differentiation of f with respect to the x. Then here comes the q. The q is being partial differentiation of f with respect to the y. Then here comes r, dou square f by of dou x square. Here the major mistakes takes place. S is not been dou square f by of dou y square. No, it is been dou square f by of dou x dou y. And here comes t. And here this has been dou square f by of dou y square. And as we are in search of a stationary point at very beginning, we would be focusing over p and q. We would be focusing p and q. Yes. And we will be comparing with 0. We will be getting the stationary point, and with the help of few more process, we will be getting to know whether that stationary point is being the point of maxima, point of minima, or the inflation point, or the saddle point, or the saddle point. Yes, yes. So this process has to be followed. What we are going to do over here now, dou f by of dou x is being 0, dou f by dou y is being 0. Same, all process has to be followed. By keeping p is equals to 0, q is equals to 0, you had to get the stationary point. Probably the student who must have practiced a bit about the maxima and minima with the two variable could have a little bit idea about it. And at last, what we are going to do over here, see, now test is being performed, RT minus of S square test. If RT minus of S square test is being greater than 0, no, then only the extrema would take place. Yes, either it could be minima, either it could be maxima. How do we know whether it's been the minima or maxima? RT is minus of S square is been greater than 0, and if R is been greater than 0, that point is being the point of minima, otherwise it's gonna be a point of maxima. Otherwise it's gonna be a point of maxima. Now, if RT minus of S square is being 0, then we need to investigate the given function with the help of few more steps of humans. Yes, and if RT minus of S square is been lesser than 0, then the neither maxima or nor minima is been taken place. It's been a point of inflection. It's been a point of inflection. So let me do one thing. Let me take few number of numericals now. Now I would like to have the input from each one of you. Probably you guys must be able to crack this problem out. See? So here comes few number of questions. So question number 16 had come in front of you. This problem has been experienced by the electronics people. In year of 2012, the problem was framed by IIT Delhi. Tell me what would be the best most answer. Yes, tell me what would be the best most answer. Here we need to find the maximum value of this function, and that too within the closed interval of 1, 6. I would like to have the input from each one of you and would like to have the answer from each one of you. Tell me what would be the best most answer for this given question. Let me check it out. The quality of video, everything has been perfect now. Let me check it out. Till that period of time, Get me the exact answer for this given question. Get me the exact answer for this given question. Tell me what would be the best most answer for this given question. Let me check it out whether the quality of video and audio, everything has been perfect or not. Let me check it out over my YouTube. Tell me what could be the best most answer for this given question. Tell me. What would be the best most answer for this given question? So the same procedure has to be followed. May I know what is it? First, we would search for a stationary point, the point at which the slope offered by the f of x becomes 0. That could be the point of maxima, point of minima, or even saddle or inflation point. Yeah. For that, we had taken the reference of f of x that had been clearly given along with this problem, that's been x cube minus of 9x square plus of 24 of x plus of 5. We will take its first derivative. It is going to be f dash x is equals to of 3x square minus of 18 of x plus of 24, and now the differentiation of 5 is being 0, and that has to get compared with 0. That has to get compared with 0. No, I am very clear about it. Important problems pattern. That I can give. That I can give. Sir, can you please provide the PDF of some important problem patterns? Yeah, that I can give. Yes. Now, the few of the factors are being common in all of three terms that can be taken out and can be shifted towards the right hand side. So the factor which had been left out is being minus of 6 of s plus of 8 is equals to 0. 0. Yes. So obviously with the help of middle term split, you can solve this problem very well. May I know what would be that? And you had to have a clear cut idea about the middle term split, because now the physical calculator is not there in your hand, and the calculation of a quadratic equation with the help of Sridharacharya rule becomes a little bit difficult. So you should have a clear cut idea how do we split the middle term and we get the roots of this given quadratic equation. So here it is going to be minus of 2x minus of 4x plus of 8 is equals to 0. That is fine, sir, no issue. In the same sequence, if we'll be moving forward, the x can be taken common, so the factor which has been left out is being minus of 4, x minus of 2 is equals to 0. So the x is being plus 2 and plus 4, which had been satisfying my requirement. Yes. Now in the next step, we will be taking the double derivative of the function as well. First derivative is already been there in front of us. We will take its double derivative. So here it becomes 6 times of x minus of 18. We had got the two stationary point. Let me feed both of the values. The first is being at x is equals to plus 2, and the second is being at plus 4. Once we'll feed x is equals to of 2, it is going to be 12 minus of 18, and that had been minus of 6. That means at x is equals to plus 2, the maxima is going to take place at x is equals to plus 2. Point of maxima is going to take place. Yes. Yes, na? Now in the same sequence, what had been happening? Now if we had fed x is equals to of plus 4, what had been happening? Now 6 4 ja is 24, 24 minus of 18, that's been minus of plus of 6. And now you yourself would be able to understand at x is equals to of. At x is equals to of maybe what plus 4, the minima is being taken place. So what I would say, whenever you have a problem related to the maxima and minima, no, at least you had to have a tentative curve in front of you, and once you have a tentative curve in front of you, no, you would be able to smash any kind of problem. So one thing has been quite sure, at x is equals to 2, maxima has been there and minima has been there. So yes, like this it had been, like this it had been. Nowhere the sign change would take place before plus 2 and after plus 4, because if the sign change must have been taken place or the slope must have been taken place, change must have been taken place, those points must have come as a stationary point, and this problem contains only two stationary points, so the sign change would take place only and only at two different points. So here it comes, and here it comes. Yeah. In this problem, they had been talking about the maxima which can offer within the 1 comma 6. May I know where the 1 is going to come and where the 6 is going to come? Here comes x is equals to plus of 1, and here comes x is equals to a plus of 6, because here we had the x is equals to a plus of 2, and here we had the x is equals to a plus of 4. May I know where the maximum value of function is being expected? Where the maximum value of the function is being expected? One thing has been quite sure. Once we start looking the maximum worth between x is equals to 1 to 6, if we'll compare the value of function of x at x is equals to 1 and at x is equals to 2, definitely one thing has been quite sure. At x is equals to of 2, the worth of function f of x would be greater. Why? Because here the function has been monotonically increasing. Now similarly, once you'll go till x is equals to of 2 to x is equals to 4, or I would say x is equals to 1 to x is equals to 4, the maximum would take place at x is equals to plus 2 only. But after x is equals to 4, again the function is being keep increasing, and even the function may get increased beyond the function worth at x is equals to 2 itself. So whenever you had this sort of problem, no, you had to do the test, and you had to perform the test at x is equals to 2 and at the same time x is equals to of 6. Wherever the worth of the function is being maximum, that would be the maximum worth of the function within the x is equals to of 1 and 6. Within the x is equals to 1 and 6. Is that part clear to all of us? So what we are going to do over here, we would be feeding x is equals to of 2 over here, we would be feeding x is equals to of 6 over here. Tell me what are being worth over here. X is equals to 2, x is equals to 6, 2 and 6. Let me feed the values and get the answers over here. So here it becomes x cube, x to the power of 3 minus of 9 x square, and here comes 24 of x, 24 of x plus of 5, plus of 5. Yes, so I need to solve for x. No, yes, tell me, calculate. X is equals to, first I have kept the x as 2. The answer which had come over here, it's been 25. It's been 25. Similarly, calculate. X is been 6 now, and here the answer is been 41. I know many of the students must have thought that the maxima has been occurred at x is equals to 2. So the maximum value would also be appeared at x is equals to 2, which has been wrong over here. So maximum worth has been found at x is equals to 6, and that had been 41. 41. Yes. How many answers we had received so far from the Harsa? Khawas, the answer is been B, which is absolutely wrong. From the Rohit Hadap, the answer is been 42, that is also wrong. Okay, 4 and 2 you were talking. 25 is also wrong. So one of the important learning we can extract from this problem, you should not say where the maxima is being taken place, there only the maximum worth of the function would be arrived. You yourself would be able to understand, no? The function is been continuously, monotonically increasing. So sometime even it would also break this break point and it would go towards the higher side. So you must have taken the value at x is equals to 2 and value at x is equals to x. You could have got the answer. You could have got the answer. Yes, na? May I know how many of us could get the answer as a 41? I can understand most of us could not get the answer as a 41. May I know how many of us? Okay then. Okay then. Okay. 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 Okay then. Let me go back with few more important theories. There we would be taking few theories from the series expansion and at the same time mean value theorem as well. So this point is been over now. Now we are going to discuss a bit about the concept of continuity and differentiability. What does that mean by the continuity? A function is said to be a continuous function if the pen has not been lifted at a certain point to draw the complete curve. If the pen has been lifted, there the function is going to be discontinuous, and if the pen is not been lifted, the function is going to be continuous over there. Is that part clear? That's it. How mathematically is being defined? The mathematically a function is said to be a continuous function if left hand limit, a right hand limit, and the worth of the function at that point, all three had been found to be same. That means just before, just after, and the point at x is equals to c, all of three values are being same. All of the three values are being same. Is that part clear? So probably you must have known about it. And similarly, what about the limit existence? The function is said to be existing its limit if its left hand limit and right hand limit is being same. Just before and just after, the value of the limits are being same. Probably you must be knowing about it. And similarly, if we'll talk about the differentiability test, may I know where the function are not been differentiable? My dear friend, first try to understand in this way. If the function is not continuous, by default the function would not be differentiable at that point. If function is being continuous, the function may or may not be differentiable. How it's been defined? If the function makes a cusp at a certain point, in that point the unique tangent cannot be drawn over that given function, and hence the slope cannot be calculated, and as the differentiation calculates the slope, its differentiation has also not been possible. So I would say wherever the pen is been lifted, the point is going to be discontinuous. If the pen is not been lifted, the given function is going to be continuous at that point. And if you want to check the differentiability at that point, what you have to do, you have to see whether the cusp is being formed or not. If the cusp is been formed, that's it. The function will not be differentiable. If the cusp is not been formed, the function would be differentiable. Function would be differentiable. Yes, na? And this has been the test. This is called the differentiability test. This is called the differentiability test. You can have a look of it. You can have a look of it. Differentiability of a function at a certain point. At a certain point. So let me take or let me design few number of questions based on the concept of differentiability. 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 Let me take few number of questions. I would like to ask from each one of you whether the function is being differentiable, function is being continuous, limit do exist for the given function or not. Let me take a problem. Let me take a problem. F of x is equals to, let's take x for x greater than equals to, no, not greater than equals to, lesser than equals to of 1, 1, and 2x minus of 1 for x greater than equals to of 1. I would like to ask from each one of you, comment over its limit existence, continuity, and differentiability over the change point where the nature of the function is being changed, and that had been x is equals to of 1. X is equals to of 1. Tell me, among three, which is okay, which is false, which is okay and which is false? The function f of x is being x for the x lesser than equals to of 0, and similarly f of x is being 2x minus of 1 for the x greater than 1. And now we had to find out among the three different tests, the limit test, continuity test, differentiability test, which are being okay and which are being wrong. Or I can say the limit do exist or not, continuity do exist or not, and differentiability do exist or not. I would like to have the input from each one of you. I would like to have the input from each one of you. Tell me, out of the 3 different tests if you'll perform, which test would get passed and which test would get failed? Limit do exist or not, it's been continuous or not, whether the differentiability test exists or not for this given question. For this given question. Differentiable as per the Rohit. Rohit, check once again. Check once again. Somewhere mistake we had been doing over here. If you'll draw this graph, no, you yourself would be able to understand among 3 tests which are been the correct one and which are been the mistaken one. I had taken an xy plane. Here comes the horizontal axis x, vertical axis y. See, f of x is being defined as a x. Obviously, it is going to be a straight line passing through the origin having the slope is equals to 1. That is for more than 0. Yeah. So it is going to be something like this. It is going to be something like this. Yes, no? And this would prevail till x is equals to of plus of 1. So here comes x is equals to of plus of 1. Here comes x is equals to of plus of 1. X is equals to of plus of 1. May you know what would be the worth over here? The worth is simply going to be x has to be fed as a 1. So worth is going to be 1. And keep in mind, the f of x at x is equals to 1 is going to get decided by x, and after that it has to get decided by the 2x minus of 1. That means at x is equals to 1, this x is going to make a dot over here. It's going to make a dot over here because at x is equals to 1, the worth of the function is to be decided by the x itself. So here this has been the graph of x. Now, if we'll talk about the 2x minus of 1, may I know what does that mean by the 2x minus of 1? Once again, if we'll feed x is equal to of plus 1, 2 minus of 1, it becomes again 1. That means x is equals to of 1 plus onwards, again it would take the worth as plus 1, and from there onwards it would take another straight line, but there the slope would be 2. Here the slope was 1 and here the slope is 2. So here you are going to get something like this. You are going to get something like this, Agreed, no? Yes, sir. Agreed. And here the whole would be made. Slope of x is being 1. The slope of 2x plus 1 is being how much? 45 degree. Oh, sorry, 2. Now I would like to ask from each one of you what could be the best most answer. My dear friend, one thing has been quite sure. At x is equals to plus 1, the function remained continuous. Before x is equals to plus 1, the worth of the magnitude is being plus 1, and just after 1, the worth of the magnitude is being plus 1. So I would say the left hand limit and right hand limit remains very same. The worth of the function at f1 minus and f1 plus remain very same as 1 itself. Left hand limit and right hand limit is being very same, so the limit do exist at any cost, at least in this problem. Limit do exist. Now we'll be talking about the continuity. My dear friend, how the continuity is being defined? The continuity is being defined that whether while drawing the f of x, the pen should not get lifted at x is equals to 1. That means f of 1 minus has to be equals to of f of 1 plus has to be equals to of f of 1. This 2 factor is already been defined as 1. And now at x is equals to 1, the magnitude would be asked from its dot, and the dot is being placed at 1. So obviously, sir, I can say, yes, sir, it had been continuous as well. It had been continuous as well. Yes, no? Now, if we'll be talking about the differentiability, either you can go through the long process of mathematical calculation, or straight away with the help of aptitude, you could have seen there had been a sudden bump over the slope. Earlier, the slope was continuously processing with 1, but it had been bumped to 2. So I can say the slope, I would say the slope of the given function at x is equals to of 1 minus was 1, and differentiation of the function at x is equals to of 1 plus has been suddenly changed to the plus 2. That means the formation of the curve is being taken place, and as there has been the formation of the curve, by default the function is not gonna be differentiable at this point. Differentiable, not at all. Continuous, haji. And similarly, limit, no sir, not at all. Yes, it is also exist. It is also exist. So this sort of problem may come in your examinations as well. So you have to get prepared for this sort of problem as well. Agreed? No. Now, let me take few more number of questions based on the concept of okay, no issue. So now I am going to take a limit, no issue. Now I am going to take the next important theoretical parts, and there I would be discussing about different mean value theorems, So let me focus over that as well. So here comes the mean value theorem. My dear friend, basically we are going to deal with three different kinds of mean value theorem. All of them had got the different strategies and different outcome. R, L, and C. R stands for Rolle's, and similarly L stands for Lagrange's, and C stands for Cauchy's. Let me focus over the Rolle's mean value theorem. F of x has been the real valued function such that, what does that mean by the real valued function? That means at any cost, if the x has been fed, the f of x should not be a complex number. Like if you had a problem like you can say root over of x. If you feed x is equals to of minus value, it would result a imaginary. So anyways, those functions are being ruled out. F of x has been continuous over the closed interval of a comma b. That means the study had been made over a closed interval of a comma b, and there the function of f of x is being found to be continuous, and similarly f of x is being differentiable over the open interval of a comma b. Now let me talk about the Rolle's mean value theorem. As per the Rolle's mean value theorem, if f of a is being f of b, there must be a point c in between a and b where the slope must have been 0, and that is been a genuine point. Why so? We know the height at x is equals to a and height at x is equals to b is being same, and that's been possible only and only if the turning must have been taken place. Like if the curve is been decreasing over here, and just to maintain the same height, it has to increase its magnitude, and as it has to get increase its magnitude, somewhere a point x is equals to c would take place where the slope would become 0. That is for sure, no issue at all, even it could be two times as well. It had been increasing, it had been increasing, it had been decreasing, and it had been further increased. So now we have got the two different stationary points, c1 and c2. So this is for sure within x is equals to a and x is equals to b, if the function is being continuous and differentiable, and at extreme values of x is equals to a and b, the worth of the function are being same, definitely at least one point c would fall within the span of a comma b where the slope has to be 0. Yes, na? Yes. So whenever you had this sort of problem where the worth of the function at two extreme values where the analysis has been made is been found to be same, by default that problem would be the problem from Rolle's mean value theorem. Now in the same sequence we had been moving forward, and now we had been talking about the Lagrange's mean value theorem. Lagrange's mean value theorem, I can say, has been the extension of Rolle's mean value theorem, or even the Rolle's mean value theorem can be concluded or can be analyzed with the help of Lagrange's mean value theorem as well. Starting two components are been very same, but here the f of a is not been very same as the f of b. And now the problem says a point c would fall in between a comma b such there the instantaneous slope of the function would be the average slope of the function. How will you get the average slope? My dear friend? The average slope would be the net change in y versus net change in x. The net change in y versus net change in x. How will you get the net change in y? The net change in y is nothing but, you yourself would be able to understand, f of b minus of f of a divided by of b minus of a. If you are not able to understand, let me explain a bit. Here it is going to be f of a. This has been this coordinate, and this coordinate is being bf of b. Yes, and you yourself would be able to understand its average slope would be shown by a straight line, and in between you yourself would be able to draw a tangent over this smooth curve where both had been parallel to each other. So according to this theorem, it's been said it's been said at least a point C would fall in between, where the instantaneous slope would be very same as the average slope. Would be very same as the average slope. Yes. So here comes the Cauchy mean value theorem. Cauchy mean value theorem. So far, what's the mean difference? Cauchy mean value theorem. In Cauchy mean value theorem, basically we had been dealing with the two different functions. Let's take the function is being f, the function is being g. Yes, so here it becomes f of b minus of f of a, g of b minus of g of a, g of b minus of g of a. Yes. Yes, now let me take few number of questions. So maths marathon, come over here. So this question goes to you guys. You have to get the answer for this given question. You have to get answer for this given question. Yes, tell me. You had to give the answer for this given question. I need the answer from each one of you. I need the answer from each one of you. The problem states the Lagrange's mean value theorem, which we also call it LMV theorem, is satisfied for fx is equals to of x cube plus of 5 in the interval of 1 comma 4 at a value rounded off to the second decimal place of x is been. Tell me what could be the best most answer. What could be the best most answer? Tell me what could be the best most answer for this given question. Tell me, my dear friends. I would request to each one of you, the student who had been attending this session sincerely, this should also respond. So, two-way communication has always been the best way communication, at least in case of live classes. So, you as well as me, both would be enjoying together. See, again, it had been clearly stated, it had been satisfying the Lagrange's mean value theorem. So, according to the Lagrange's mean value theorem, in between a comma b, the problem has been clearly stated, the value of a is been 1 and the value of b is been 4. There would be a point C. So, whatever the answer do come, no, definitely it has to be in between 1 to 4. It has to be one in between 1 to 4. That is for sure. And that must satisfy the basic requirement of LMV. And that states the instantaneous slope of a function at a point C would be very same as the average slope of the function. And that is been f dash C is equals to of f of B. So what we are going to do, the 1 would be kept over here. So 5 plus of 1, that's been 6. And similarly 4 would be kept over here. So here it becomes 4 to the power of 3 plus of 5 minus of 1 to the power of 3 plus of 5, and towards denominator side we are going to have b minus of a. 4 minus of 1. 4 minus of 1. And once you'll subtract it, the result is supposed to get, it's been 3. It's been 3. Put together, this 5 and 5 is going to go out. 4 to the power of 3, that's going to be 64, no? Yes, 64. 64 minus of 1, it's going to be 63 divided by of 3. And that is going to be how much? 2, 1. That means you had to perform a differentiation of the given function. and in between a point C should come where its first derivative would become 21. So let me take its differentiation. So f dash x, keeping x is equals to C, we had to compare that value as 21. That value is 21. Yes. Is that part clear? So now from here you will be easily able to get the answer. Tell me what would be the best most answer? So what we had to do, we had to take its differentiation, that had been 3 of x, and you will be getting the answer. So the answer would be coming somewhere in between 2.6 to 2.7. 2.6 to 2.7. Is that part clear? Now I expect apart from this, the complex variable is not been there in part of civil engineering, and similarly numerical method is not been part of electronics and electrical. So I need not to focus much on that. Let me take few number of numericals only, and then we would try to bind up the today's session. So let me take few number of numericals. Yes, question. So here comes the next question. Here comes the next question. The concepts from the limit. Concepts from the limit. Concepts from the limit. Yes. The last question. Yes. The last question. And now I would request to each one of you, that part has to get prepared by yourself. Yes, the probability, it's all about doing the practice that you had to done by yourself. Complex has to be done by yourself, and similarly numerical method has to be done by yourself. Why I'm not taking this? Because the probability, I can say, it's all about the practicing. Yes, if you guys could have given the good amount of responses, definitely I could have conducted the separate session for the probability itself, but no issue. Complex and numerical method, why I'm not going to take? Because this has been a topic where complex is not been there in civil engineering, and numerical method is not been there in electronics and electrical. So yes, this would be the last question. This would be the last question. So L hospital rule has to be applied 0 by 0 case, and you had to differentiate, and once the answer we will be getting, the answer would be simply C. Anyways, my marathon on engineering mathematics is almost going to come at end, and I had been expecting more response from you guys, but I can understand the gate had almost come near to you guys, so nobody wants to learn something new. All of us or all of the students might be busy taking their all of the revisions, so definitely I can give the respect to your that methodology to understand, or that methodology to study as well. But no issue. If you guys are having any kind of doubt, if you want any certain kind of tips, so you can ask from me. Otherwise we will bind up the today's session here itself. Okay, then we are just binding up our marathon on mathematics. Till then, bye bye, take care.